Hey everyone, it's Matt from Zenshop, and I wanted to give an update on some of the stuff that I'm working on for the next release. So as I mentioned in the previous video, I'm starting to work on a production environment to test all of Zenshop's features. So I can show you some progress here, because one of the things that came apparent to me was I needed to optimize a whole bunch of SQL queries and things that Zenshop does to make it fast. Because when you're testing it on your local environment, it can be a little bit deceptive. Everything seems super snappy, and you don't know whether there's actually performance issues or not. Particularly if you're running on an M1 MacBook like I am, because this M1 MacBook is super fast and it makes all of your code really, really quick. So now that Zenshop's running in the cloud, as you can see here in the browser, it's running on a real server, and there's often, it's not necessarily the CPU which is causing the slowdown, it's actually latency. So the latency between either the web process and the database, or yourself and where the server is located. Or there might be external services that the web process might be calling out to, and then that slows things down. There's a whole bunch of different topics that I'm tackling right now, but they can be broken down into two main sections. One is read performance, and the other one is write performance. So read performance is when, for example, I'm clicking on a tab here, and then I'm reading from the database. So here, for example, I've loaded up some customers. And here, for example, I'm just loading up conversations. Now, when you tap between these, it's super quick, right? And I wanted the experience to be as quick as possible. So I didn't want to show loading spinners each time you go to each tab. And what the reason why it's doing this is several things. One is the actual query is quite quick. So when I go and fetch data from the database, it's very fast. And the other thing is the front end is doing some types of caching. So when the front end displays that page, it's going to its local cache and checking if it's got anything previous for that query already in its cache, and then showing that to the user. And then after it's shown it to the user, or even as soon as you're loading that page, it's showing you the cache result, and then it's going in the background and then fetching data from the live source and then updating that in place. So for example, if you go to this tab, now it's going to show you that cached data, but if there are any changes to one of these customers, like the name or an email or something, or total spend, it will then go and update that in place. So the other thing I've been working on is actually the query. So I can show you, for example, now bear in mind this is still in development, so there's things about these queries that I'm still optimizing that I can probably talk about in a minute. But one of the cool things about Zenshop is it's using a GraphQL API. Now, if you're not familiar with GraphQL, essentially you might be more familiar with REST, for example, as common API delivery. But GraphQL is smarter, and what it allows you to do is make intelligent requests to your backend for the data that you need. For example, if I go to the address book, you can see a GraphQL API request here, and it's fetching me customers, and it's returning some fields for each of these customers. Now, what I've been trying to do is flatten these API requests as much as possible, because it's quite common that when you get complicated data sets, and Zenshop's quite complicated, it has a lot of different things about it in the data, that you can have very nested API responses, and flattening it out means that when I do the request to the database, I'm not fetching lots of different tables and doing a complicated SQL query. I'm actually fetching data just in that table. So for example, here I've got the total spend of the user, the number of orders, their email address, their last order date, that kind of information. And that's only the information which is shown in this table. So it's not overfetching data, and it's fetching data within that one table. So one of the things that when they teach you, and this actually I got sort of inspired from a friend, Tom. Shout out to Tom if he's listening. But he kind of reminded me that when you're doing SQL kind of queries, you're taught to normalize your data. So that means you won't have any duplicated data in your database. But that's actually not good advice when you're trying to do performance, because here I haven't normalized the data, but it's quicker. And the reason why is because when I need to go and fetch, for example, the number of orders, that's an additional SQL query that I don't want to do. So what happens is every time there's a new order come in, or a new conversation or message or something, it's going to update the customer table with that additional information. So that means that write speed is lower for those instances because it's having to update an additional table. But that means that read speed is faster. And most of the time you're doing reads, right? A lot of the time you're just browsing the website and you're reading data. And then when you come to do your writes, those things are slower now. But there's actually strategies to improve that as well, which I'll go into later. So that's an example of how I've made the address book, for example, quicker. The other thing as well is actually pagination. I've been working hard on doing this pagination to make it faster as well. So you click here and it loads another set of the data. And the reason why is because this one field here needed some additional code in my backend that basically tells me how large this data set is. Just because of the way GraphQL works, it uses cursor-based navigation, and this field is typically left out, and I wanted to actually display that. And previously I was doing 2 API requests. I was doing one API request to fetch the number of customers, and then additional API requests to fetch this data, and that's bonkers. So now it's just one API request and one SQL query. So the other thing as well is this interface here is a lot more complicated. So let's just bring this down a bit. And it's showing lots of information, right? So these SQL queries are more complex. So if I tab between these, you can see now that it's really fast, and I want to keep that speed. The same with these as well. It loads the data, and then I can go back here. It's fast. It's slow. It's fast. And if I go to the network tab and clear it, so for example, if I click here again, you see it's shown the data really quick, but it's also done the query. So it's not it's just showing you local cache data and done with it. It's showing you local cache data immediately, and also doing the query to fetch the latest data. And that means that whenever you go to these pages, it will always be showing you the latest information. One of the things as well here, for example, these API requests, these are even more complicated because it's bringing in the full conversation. It's doing lots more queries to the back end for different sorts of data, mostly around like the order or something like that, or the timeline. So there's a timeline to the conversation, and it's fetching information around that. But it's all really, really quick. And again, like when you're a customer support agent, you quite typically deal with multiple tickets. You know, you're not just working on one ticket. So that might involve tabbing between different conversations. So here we've got this little menu bar at the top, and it lets you just switch between different messages. And what I'm also going to be working on is the ability for the backend to like notify you of changes within the conversation as they happen. So for example, let's say you're talking to Tanisha here, and you're messaging them and, you know, making a reply, but then, you know, Jamie messages you. You know, you want to know as soon as possible that Jamie's just responded, so it will just like pop up a little badge like this, for example, on top of here. And it might even like pop up some, you know, like notification just to let you know that Jamie's responded. So that requires some work, but I'm looking forward to doing that. And the other thing as well is I didn't show you this last time, but this is the help desk. Now it's also running on the production environment. And one of the things I've noticed, which I'm going to fix, is just like the load speed at the help desk needs some improvement. It's not super major, but it kind of shows you the difference that front-end caching does. So for example, when I click on this article here, you can see when I go back, there's that's kind of like jank in the rendering. There you go, you can see it again. And that was actually due to the fact that what happens is when it loads that page, it's having to fetch the data for the help desk. But it's already got that data somewhere. Well, it actually hasn't got that data, but it can have that data, and it can store it in a memory rather than just sort of showing you that blank page. I'm going to show you the cached version. And, you know, update it similar to how the other tabs here in zenshop work. But it's good to see that zenshop is working now with the help desk as well on a production environment. One of the other things I need to also do, which I'm looking forward to working on soon, is search optimization. So for example, let's say I'm looking for this is Jamie again. So I search for Jamie. There's only one. Let's maybe find another one. Kent. I think Kent's got some. Yeah, there you go. So like Kent has got like four conversations going on there, and this search is really, really good. Like I'm using Algolia, which allows me to do like lots of really smart things with prioritizing search results and getting really relevant search results in here. But one of the things I've noticed is that when I'm doing a write operation to the database, it's actually slowing it down, and that's because every time it does a record change on the database, it's having to send that data to Algolia so it can index it and, you know, do all the smart things that Algolia does. And those are blocking kind of requests. So what would be better before I launch this on production is to make those operations run in the background, and that way they're not blocking. So I'll give you an example, but one of the things I've got the feature of here, we just go on another page, is I can click on these and then I can do a bulk action, and I can I'll mark them as spam, for example. Now, when you do that bulk action, it's quite slow at the moment because it's doing it like one by one. Each of those conversations, it's updating them and so on. And it's also having to tell Algolia that this conversation is now changed, and it's sending the data to it. Now, I want that to be faster. And I'm going to do some of those things more on the background thread rather than processing them straight away. But that also means that when you're doing a search, those search results might not be 100% accurate because they haven't actually fully updated yet. But I'm willing to accept what's called eventual consistency within the search results. So it's not immediately consistent, but it will become consistent with time. So yeah, that was also an interesting thing I discovered when testing this in the production environment. So yeah, it's definitely coming along. Lots of bugs, squashing, lots of performance issues, but super fun. Really enjoying this part of the process of launching this next version. I'll give you another update with more things. Thanks very much for watching. Bye.